Hello everyone. Let's Hello everyone. Let's wait for like 2 to 4 minutes and then we'll start. Okay, so let's get started. It's time for 30 days of Google Cloud program. And so yeah, we have been getting a lot of DMs regarding how do we prepare for cloud careers. As we all know that cloud is a booming technology these days. And all the IT companies across the world are shifting their traditional infrastructure to the cloud. So this particular shift is generating a higher demand of cloud engineers. Now, using the resources which we will be providing in this particular program, you can make yourself eligible for such positions. And there are so many other peeps who are asking that since we are part of a reputed university, is that enough for to make us eligible for this particular cloud engineering position? Well, the answer is no. The university education provides a strong theoretical foundation, but you will need strong industry skills to launch your careers. Okay, and so let's begin with 30 days of Google Cloud. Contents of this particular program. We have two tracks. First track includes cloud engineering, and second track is data science and machine learning. And yeah, in track one, in track one, we'll be discussing about the deploy solutions elements, and this includes from creation of virtual machine till deploying your whole application on Kubernetes cluster. And we will also look about how do we set up the alerting policies and how do we do logging of all your application logs and everything. And track 2 is data science and machine learning, and this will help you demonstrate proficiency in key topics related to big data and machine learning to prepare for such roles like data analyst, marketing analyst, business intelligence professional, etc. etc. This track consists of 6 quests, as I said before. Yeah, and so this will give you a basic overview of how to use Google Cloud machine learning APIs such as speech API, translation API, and so on. We'll discuss in brief in some time. Let's move forward. After completing each quest from either of the tracks, you will have a chance of earning skill badges, Google Cloud skill badges. The skill badges are used to show that you are actually applied for the quest and you completed the quest and you gain the skill out of it. And you can share them on your Twitter, Instagram, and LinkedIn. and etc etc. Do tag us. Okay, let's just check if anyone have any issues over here. Okay, I guess all good. Let's continue. Okay, there are three main types of cloud-based services. One is infrastructure as service, one is platform as service, and the other one is software as service. Let's go in depth of every single one. When you consume infrastructure as service, you have a greater control over the resources. For example, consider a virtual machine. And what is a virtual machine? Just give me 2 minutes, I'll explain you. Yeah, and you will need to install, upgrade, and patch all the software required for to run your application. And infrastructure as service helps you get additional control over the actual infrastructure raw component. Okay, so you can do updates, you can do patches, you can do anything whatever you want to. Okay, can you see my slides? You can't see my any slides. Oh shit, sorry. Is it visible now? It takes up to 30 seconds. Cool. Let me just go through all the slides whatever I have discussed, and these are the slides you can have a go through. If you want, let me know, I'll just explain everything again by showing slides. Cool. So let's continue. Okay, these are the quests inside the track 1, cloud engineering, and these are the quests inside track 2, data science and machine learning. Cool. Let's go to infrastructure. Let's go to platform as service. Just give me a sec. Yeah, platform as service provides a platform with managed services when runtime environment and network settings are pre-configured. So one of the example of Google for platform as service is Google App Engine. And Google App Engine comes with pre-configured runtime environments such as Java, Python, Node.js, etc. etc. Software upgrades and patches are automatically applied by Google Cloud, and load balancing is pre-configured. And what is load balancing? Just give me some time, I'll explain you in this webinar itself. And this okay, what is the main advantage of platform as service? So when you consume platform as service, you can think about you have to focus more about application logic than worrying about the infrastructure setup. That's the main advantage of platform as service. And let's get started with SAS. Okay, with software as service, the entire application are managed and made available in the in the cloud environment. And Gmail is an example of SaaS, software as service. Let's take an example of a gaming application. And so let's see how Google Cloud helps you in making gaming applications. For example, we can take any example of a game, but I'll just go with a normal example. So let's have a game which has some images. Okay, all your images can be stored on Google Cloud Storage, and uh, since it's in a game, you have some 3D object streaming directly onto your mobile. So we need to have some high level storage solution which has high speed of transmission of all the storage all the objects inside the storage bucket. And for that we have Google Cloud Storage, Cloud Data Store, and Google Cloud Bigtable, which will help you transmit high volume or semi structured data like streaming or gaming data. And then we have Cloud SQL and Cloud Spanner. This is a relational database services of Google Cloud which helps you store any data such as username, emails, passwords, whatever you want to store about the user or anything related to that. Okay, and let's come to the application logic. So over here, two really good platform as service solutions are App Engine and Container Engine. So in App Engine, you don't need to worry about infrastructure, as I said before, since it's a platform as service, and you write your business logic over there. Suppose, for example, if you want to do a Google OAuth sign in, okay, you write your logic over there, and it will be deployed, and it will be scaled based on the load. And what is scale based on the load? Give me some time. Yeah, and Container Engine is basically for deploying all your Docker images on Google Cloud. And what is Docker image? We'll discuss. Okay, yeah, and you can integrate with other Google services such as Google Maps, YouTube API, and Google Auth, etc., etc. That's a full-fledged example of a running application on Google Cloud. And just before getting on to the actual concept, we'll discuss the very important feature of Google Cloud, that is IAM. Okay, identity and access management. I'll explain you this with an example. Let's suppose one of my friend named Hisham, and he wants to work on the same project in which I mean he wants to work on the same project. Okay, and I should give him an access to create a new virtual machine, but I should make sure as well as I should make sure that he doesn't delete my projects which I already made, or any resources which I already made. And how do I restrict him that with that? And there comes the concept of IAM. Okay, right now you can define the access management rules for every single user, whoever you want to give access to. In this case, who it is Hisham, and can do what? Create a virtual machine on which resources? Google Compute Engine. Virtual machines come under Google Compute Engine, and that's why we'll say on Compute Engine he can only apply create virtual machines rule. And then who can do that? Only Hisham. That's all about IAM, identity and access management. Okay, and there are so many people who are asking what is regions, what is zones, and why is it important. Let's get started with a zone. A zone is an isolated location within a region, and you can think of this as being a simple data center. A zone is designed and set up to be independent from other zones within a region. And in the rarest case, the one if one zone goes down because of any natural disaster or network issues or network outage, okay, the all the other zones will be operational and will make sure that your website is not down. This is the main advantage of having multiple zones inside a region. And what is a region? And regions are basically collections of zone. Okay, regions are independent geographic areas that consist of zones, and locations which within the region, okay, have high 5 milliseconds. Okay, there's some network lag. Am I audible now? Am I audible? Okay, there was some issue. Yeah. So regions are collections of zones, and they're independent geographic areas spanned across the whole world. So whenever you choose a region nearby your customers, not you, nearby your customers, they will experience relatively a uh, lesser network latency. Okay, that's all about regions and zones. And your resources can be regional, zonal, or in some cases multi-regional. Let's get on to the prerequisites. And these are all the basic commands of Linux which will help you do your make your job easier. Okay, I hope the screen is visible. Okay, I have a folder over here and I want to see all the contents inside this folder. And how do I do that? From a command terminal. So I'll just type ls, and ls is nothing but a list, okay, which gives me all the files inside that particular folder. Over here I have hello.txt and txt folder, okay, tst folder, sorry, yeah. And for suppose if I want to make some, I mean if I want to see all the hidden files inside this particular folder, I'll do ls space minus a, and that shows me all the hidden files. Right now I don't have any other hidden files. Let me make a hidden file. To make a file you need to type touch space your file name. Over here .env is a hidden file, so I'll just make that, and you can see over here you get .env, and if I remove minus a flag I won't be getting .env, okay. And let's okay, there's one more case which I need to discuss. Okay, let's assume that you want to see the file sizes of each file or folder size. So what you do is ls space minus l flag, and it will show you the file size or folder size, correct. And that's all about ls and its flags. And let's move on to cat. So if I want to, 1 second, just give me a sec. Let's move on to cat. Suppose for example you want to see what all inside the folder, okay, oh, sorry, what all inside the file. So what you do is basically cat space your file name. Over here in our case it is hello.txt, and I do cat space hello.txt. I can see what are inside that particular folder. Let's move on. For now I want to go into the directory, that is I mean the folder. Over here I have a folder named test, so I'm going into test folder and see if anything is there. There's nothing, okay. And I want to see where exactly I am, so I'll just type pwd d. That will give me exact folder path of currently where I am. And now let's move on to editing the files. And here we have in this particular webinar we'll be discussing two editors. One is vim and one is nano. First of all we'll use vim and edit the file. Let's move to gcp folder, and to move back you need to use cd space dot dot. That will move back from your current folder. Now if you see pwd, you are in gcp, and before it was in test, and we moved back. And so let's do one thing. Let's edit the file whatever is there in here. It's hello.txt, yeah. Over here you have hello world. Now I want to add a exclamatory mark at the end, and to do that first you need to press and go to insert mode. And once you are in insert mode you can edit whatever you want to. And once you're done inserting all the things whatever you want to do or whatever changes you want to do, and you need to press escape. And once you press escape you go back to the normal mode, and to write the file contents whatever you change you need to do colon w, and this will write the contents onto the file, but right now I won't do it, okay. And now the other way is, if you want to quit the file you need to do colon q. That will quit the file, okay. And it shows no write since last change. That means that you have changed something but you didn't write it. And to write to write and quit we need to do wq, okay. And to just quit you need to do q. And if you want to quit without saving you need to do q exclamatory mark. That is override saving, got it. Okay, so let me revise you once again. Okay, wq is write and save, sorry, write and quit, okay. And q is quit without saving, sorry, quit, okay. And q exclamatory mark is quit without saving. And finally w is write. Right now we'll write and quit. That's it. Okay, let's do a cat hello.txt and check if the changes are done. Yeah, we have an exclamatory mark at the end. This is all about vim editor, and if you want to take a screenshot I'll wait for 2 to 3 seconds. You can take a screenshot. Okay, let's move to nano. So I want to remove an exclamatory mark now. So I'll just type nano space hello.txt, and now it directly change whatever you want to change, and just type control X, and once you do that it will ask, do you want to save? If you want to save, just do Y, or else no, that is N. Okay, I clicked on Y and it is asking the file name to write, that is hello.txt, and I'll press enter, and that's it, we are done. Let's see cat hello.txt, and let's see if the exclamatory mark is there. There's no exclamatory mark, that means nano worked. Okay, and this is about nano. And okay, just before getting onto the cloud engineering track, let's see if you guys have any questions. Cool, I don't think there are any other doubts. Let's move on. Okay, what is a virtual machine? A virtual machine is a software based computer, and likely a physical computer. It has resources like CPU, memory, operating system, etc. And a virtual machine uses the physical resources of the host that is running on. In our case, it is Google Cloud. Okay, and every virtual machine has virtual devices that provide the same functionality as hardware, physical hardware. They also have the additional benefits like portability, manageability, and security. And then you may have one doubt. Okay, so why not using our physical computers instead of using Google Cloud virtual machines? Let's assume a case. Okay, over here we have Abhishek. Okay, Abhishek is a ML developer, and he wants to train his algorithm, but unfortunately he doesn't want to use uh, IPVNB training. Okay, he wants to do it on virtual machine. So what he does is he creates a Google Cloud virtual machine using compute engine, and then afterwards he trains his algorithm, and once he is done he'll destroy that particular virtual machine. So what is happening is he's paying for what he used. So he used for 5 minutes and he's paying for that, and he's not paying any extra single penny. And that's the very main advantage of using Google Cloud or virtual machine. Let's move on. Compute Engine offers managed virtual machines on Google Cloud, and which has high CPU, high memory, standard, and shared core machine types. And it has persistent disk, standard SSD and local SSD, and snapshots. And let's get to the main concept of startup scripts. Okay, yeah, what are startup scripts? Startup scripts are nothing but a bash script which will run once your VM is booted up. For example, you want to update the update the virtual machine, I mean update all the pending updates in the virtual machine. How do you do that? Sudo apt-get update, right? So what you do is you make a bash script of this command and you put it in the configuration whenever you are making the virtual machine, and once the virtual machine is made, and these commands will be executed. Got it? And what is the use of this? We'll discuss in some time. Let's get to the main concept of Cloud Shell and G-Cloud. Cloud Shell is a Debian based virtual machine which makes it easy for you to manage your cloud platform projects and resources. The Cloud Shell VM is pre-installed with Google Cloud SDKs and other tools. It has 5 GB of persistent disk storage, and it provides command line access to all your virtual machine instances in a terminal window that opens right in the web console. That's the advantages of Cloud Shell and G-Cloud. And let's come to the concept of horizontal and vertical scaling. Before explaining the actual concept behind this, let me take up an example and explain you with that. Okay, so let's suppose we have a restaurant XYZ. Okay, and it was led by one more guy named Akshat. Okay, and since it's a new restaurant, Akshat hired an intern chef instead of going for an experienced chef. Of course, because experienced chef is, you need to pay more, right? So since it's a new hotel, he want to hire an intern chef. He hired an intern chef. After 1 to 2 months, okay, he observed that the count of people who ever reaching his coming to his restaurant is increased. So that intern chef is unable to make dishes for all the people. I mean, all the people. So what he Akshat thinks is he wants to do something so that no one will wait for more time. I mean, the guys whoever coming for the restaurant won't wait for more time, right? Customers won't wait for more time. So he has two options. One is removing the intern and giving a offer to a experienced chef, or else adding more interns, right? What do you think Akshat will do? He can do anything. Both works. Okay, let's come to the actual example. Okay, first suppose you have an application which has like 20 users, and after few days you get more users, right? And you did some publicity and marketing and you got more users, and then what you do is, since there's a 0.5 GB RAM, you just update it to 2.5 GB RAM, and that is known as vertical scaling. And or else you have another option of adding one more 0.5 GB RAM and splitting the whole traffic among each of them. Okay, this will reduce the load of on each single 0.5 GB RAM virtual machine, right? This is horizontal scaling. And how do you distribute traffic among so many PCs? And there comes the concept of load balancing. Okay, so users are requesting your application, and the whole traffic whatever you are getting onto your application will be divided among your virtual machines whatever you configured. And you can set up auto scaling policy. What is auto scaling policy? Let's suppose you have a case like at one particular time you're getting so many users, right? I mean at evening 6 p.m. you're getting like 100 users, and right after 8 p.m. it will get decreased to 20 users. If you make it in such a way that it will be able to handle all the 100 users all the time, it will be a waste of money according to me, because you are running a 2.5 GB RAM, for example, okay, all the time, and which can support up to 100 users. Okay, and rest of the time it is zero. Rest of the time it will be useless. Okay, the other way is if you fire up a 0.5 GB RAM, which can sustain up to 20 users. Okay, whenever at the 6 p.m., okay, you are getting 100 users, right? These people will experience a slow load times. And how do you handle this particular case? There comes the concept of auto scaling. What do you do is, when you do a if condition, if my request count is more than this particular number, this particular threshold value, okay, add a virtual machine to it, okay, and run my startup script. What is startup script? We discussed it over here. It's a bash script. Whenever the VM is created, it will run, that bash script will be executed, right? Okay, and what happens, the bash script get executed and your virtual machine will be up, and the whole traffic will be divided to that as well. And once the threshold is, I mean, once it becomes the decrease, I mean, once the threshold decreases, and then the virtual machine will be automatically destroyed. That's about load balancing. Let's see if you have any doubts. Okay, I don't think there are any doubts. Have you ever faced this? My code works on my machine, but it doesn't work on my friend's machine. Why? There are many reasons. One of the main reason is OS. Okay, for example, uh, where is point? Okay, for example, in this case, I have a Mac OS and my friend has a Windows OS. Okay, and I have Nginx 1.15 and my friend has Nginx 0.4, and my application, whatever I wrote, okay, will work on my PC, but it doesn't work on his PC. Okay, is there any solution for this? If yes, put it on comment section. Okay, but the solution over here is Docker. And what is Docker? It's a tool for containerization. Over here you make a Docker images, okay, which will work on my environment as well as my friend's environment. How do Docker handles it? Okay, this is your infrastructure, that is your laptop, and this is your host operating system. In my case, it was Mac OS, and in my friend's case, it was Windows, right? And this is your whole application as well as all the requirements, all the libraries or dependencies of your application, whatever you wrote, and which will be on top of Docker engine. And this whole thing is known as image, which will be running inside a Docker container. So on the whole, all your code is running on Docker engine, okay, on top of Docker engine, so which enables it to run on any sort of environment whoever has Docker installed on their PC. And that's the very huge advantage of Docker. Okay, for example, you have like 3 to 4 containers over here. One is front end, one is back end, and one is some other front end too. Okay, and in this case we have three containers, and it will be bit easy to manage all these 3 containers. Let's assume a case of very big startup, okay, which has like more than 2000 containers, and it's pretty hard to manage all these containers, right? And around PayPal has around 76,000 containers in their first year. Okay, and it will be pretty hard to manage all these containers, right? So what we do is we take help of Kubernetes. Kubernetes helps you in management of Docker containers. It also helps us in automatic deployments and scaling. Pretty sure most of you are from VIT. So let's take up an example related to VIT itself. As you all know, there are 2 main events, Gravitas and Rivera. Okay, and Gravitas is a tech fest and Rivera is one more fest. Okay, and let's assume that we have 3 containers. Okay, one container is basically Gravitas container, which has Gravitas backend. Okay, the other container is VIT's official homepage. Okay, that is vit.ac.in, and we have one more container of Rivera. So what happens is, at the time of Gravitas, the users reaching the Gravitas will be pretty high. Okay, and so we need to have something to scale the users count. Let's assume this is what happened. DSC VIT develops backend and front end for both Gravitas and Rivera, and one of the cases was they deployed their whole application on a VM using Docker. Let's try to figure out, if we deploy it using Kubernetes, what are the advantages which we will be getting. Okay, whenever DSC VIT promoted, at one particular day, at one fine day, okay, DSC VIT promoted its workshop named Build You. It's basically a portfolio website building workshop. Okay, and suddenly after promoting that particular event, around 200 to 300 people went to Gravitas website. Because of this, people are facing slow load times of the website. And how do we handle this? There comes the concept of load balancing and horizontal scaling. I'm pretty sure you guys know about load balancing and horizontal scaling because we discussed over here. Okay, there's a small change in Kubernetes. Instead of creating a new virtual machine, it creates a new container. Got it? And it distributes traffic among containers, not virtual machines. And that is the first 2 features. Okay, and let's suppose in the meanwhile there's one more dude named Shantanu. He wants to see vit.ac.in website, and so he goes to vit.ac.in website, And how does Kubernetes routes traffic? Something like Shantanu is requesting vit.ac.in, and there's one more dude named Abhishek who is requesting Gravitas website because he wants to register for build. So what happens is whenever all the requests comes into Kubernetes, it will get distributed to its respective containers using service topology. This is the job of service topology, to route the traffic whatever is getting into the Kubernetes cluster. Let's move on. And on website, on the Gravitas website, everyone will be able to say, I mean, every event has some posters, everything, right? And how to Kubernetes serve all these static files? Posters are nothing but static files, right? How to Kubernetes serve all these static files? It uses storage orchestration, which helps you link your network file system storage directly to your Kubernetes cluster, or else you can also link your GCP cloud bucket, storage bucket, onto your Kubernetes cluster. Got it? And as we all know, we should maintain few secrets, if I'm not wrong. Okay, suppose you want to mail people who have registered for build you, okay, and you are open sourcing the whole code of Gravitas on GitHub, okay, and obviously if you want to mail someone, you need to have a API key, or if you are using SMTP, you need to have a email and password, right? Whenever you have a email and password, you are not supposed to reveal that password to everyone, because everyone can mail anyone can mail anyone, right? So to do that, we need to have a .env file. It's a hidden file where you keep all your passwords, and you won't push that all the hidden keys whatever you want to keep, and you don't push that to GitHub. And you can directly Kubernetes has an option, you can directly give the env files right in the portal, where when it right in the portal whenever it is deployed. And for example, unfortunately there was a build failure, okay, and you rolled out a new version and there was a build failure, and Kubernetes is intelligent, okay, it recognizes there was a build failure and it will automatically roll back to the previous working version, so that there won't be any website downtime. Got it? So it will automatically roll back to the previous version, so that whenever even though if the web developer or developer whoever deployed rolled out the new version didn't observe that, okay, it will automatically roll back to the previous version, so website won't be down at all. These are all the other three features of Kubernetes. We have more. As we all know, since 1998, the whole world is moving towards IPv6 because lack of IPv4 IP addresses, right? And Kubernetes has IPv6 support as well. And it is self-healing. What do you mean by self-healing? For example, not in the case of automated routes and rollbacks. Suppose the container was working perfectly. Suddenly, for some weird reason, the build was failed. I mean, the container got crashed. When the container got crashed, Kubernetes Kubernetes is intelligent. It will figure out that this container has been crashed. Okay, it automatically restarts the container, or else it will provide a backup container and deletes the existing container. Okay, that is the property of self-healing. And finally, not but the least, very important, declarative. So it's pretty hard to have a console and go to every single step and do steps correctly, okay, or else it will have failure, and if you have one letter mismatch also, it will get failed, right? So Kubernetes has one configuration file, okay, you type whatever you want to have in that particular configuration file in a specific format, and it will read that file and it will make all the requirements according to that whatever you mention. Let's get back to this. Okay, so this is your configuration file and it will read, okay, and it will create all the containers which are required and starts the app and contain workers. That's all about Kubernetes. Let's see an example. Over here you have a container which has your application code and dependencies, okay, and you create an image and store it in Google container Google container registry, okay, and this is a private Docker repository for all your Docker container images, okay, and once you do that, you fire up a Google Kubernetes engine. So to start a Kubernetes cluster, okay, and it will create a nodes. Kubernetes has few virtual machines created, okay, and it will manage all those virtual machines on private network. And so these nodes are nothing but a virtual machines, and it will automatically deploy into one of the virtual machine. And so in load balancing, it won't create virtual machine, it creates new container in one of these virtual machines, okay, and it will and you will deploy this image onto the Kubernetes cluster, and once you do that, it will be live, your website will be live in no time, less than 5 minutes probably. And that's it from track one. Hope you enjoyed it, and let's see if you have any comments. I feel Google Kubernetes engine is the best because Kubernetes was developed by Google, okay, and this is the best one you could get. I mean, this is the best Kubernetes engine you could get across all the cloud platforms available. Mm. Yeah, Kubernetes engine is very confusing because it's a high level concept, but this program focuses mainly on that. Uh, what are the alternatives of GCR? GCR is Google Container Registry. So one more alternative is Docker Hub, but it is public. You have like 2 to 3 private repositories available, or else you need to pay for it. I hope there are no other doubts. Let's move forward to the second track. Let's consider an example. In this case, can you guys tell which is puppy and which is muffin? I'll wait till you guys reply. Okay, there's some lag between you and me, so I'll just proceed. Okay, according to me, the left side one is puppy and right side one is muffin. What if I tell you I give it 10,000 images of puppies and muffins, okay, and you guys sort it into a different folders? It's pretty tough, right? But it's possible. It's not impossible. It's pretty tough, okay. And now tell, is it possible? I'm pretty sure your brain will be heated up like shit. Because this is so confusing because there are so many images. I mean, a few of them very much look like muffin and few of them very much look like dog, even though they're not. And there comes the concept of machine learning. Basically, you would use the thousands of puppies photos and thousands of muffins photos to train machine learning model, so that it has enough examples to understand which is muffin, which is cookie, or sorry, which is puppy, okay. And when you throw a image at it, okay, when you throw a image at your machine learning model, it will tell whether if it is a muffin or cookie, okay. And very important tip of machine learning, good machine learning models require lots of high quality training data, right? Do you have high quality training data? Maybe no, but Google does. Okay, so and it Google has used lots and lots of training data to train its models and expose it as a machine learning API. So basically what you do is basically you will eliminate the training phase of machine learning, okay. So what you on the whole you will do, what you do is basically you will send the image to it, okay. The in this case it was puppy image or muffin image, okay, and it will tell you whether if it is a puppy or muffin with a confidence percentage. That's how simple it is. Let's see few of the Google Cloud machine learning APIs, and these are all the Google Cloud machine learning APIs, and everything all of them are self explanatory, but we'll go through it. The best example of vision is the puppy and muffin example. So you send an image, it will give all the contents of inside that image, all the objects or whatever inside the image are there. Okay. And video intelligence is basically vision for videos, I mean vision API for videos. So you send a video, it will do analytics on it, and it will say, it will tell who all are there, or if there is any sin, if there are any objects inside it, or any uh, famous people inside it. It will recognize it, and it will return back to you. And speech to text, I'm pretty sure everyone knows. So it's basically you convert audio to text. And let's talk about natural language in some time. Let's move on to translation. Okay, so translation, you can convert from Hindi to English, and so on, Japanese to English, etc., etc. And in natural language, for example, you took a speech to text API and you converted your audio to text, and you want to see how many nouns did he use, and how do you do that using natural language processing. Got it? And this is all about natural language processing and speech to text and translation, etc., etc. And these are all the quests, all the badges or quests you need to complete in track 1, and these are all the badges you need to complete in track 2. And once you're done, share your achievement on Twitter, LinkedIn, Facebook, and Instagram. And do tag us, we'd really appreciate if you do that. And use the hashtag 30 days of Google Cloud. And if you have any other doubts, you can contact me over on these social media handles. And if you have any sort of doubt in any of your labs, put it up in comment section. We'll be dealing, me and my team will be helping you out. My team and me will be helping out. Okay, I can see Vidhi asked about slide on nano once again. I'll just go back to that. Okay, there's a doubt by George. Clusters and nodes in Kubernetes. Explain this, please. Okay, let me just explain you the whole concept of Kubernetes once again. Hmm. Uh, let's take the previous example again, and I'll go a bit slow because we have time. So I'll just try to explain everything again. Okay. And so, as we all know, we have two facets in VIT. One is Gravitas, one is Rivera, and so let's make. Let's do one thing. Let's put Gravitas in one container, okay, and Rivera in one container, and VIT's official page in one more container, okay. And now suddenly on one of the pages, okay, on one of the Gravitas page, okay, due to too many people trying to register for an event, okay, the load on that particular container increases. Whenever the load increases, the response time will decrease, right? So it was supposed to load in 100 milliseconds. It took like 1 to 2 seconds because of too many people requesting it, right? So what it does is, what Kubernetes does is, okay, it just figures it out that there are too many requests coming onto this particular container. Okay, I'll do one thing. I'll add one more container of Gravitas, okay, and I'll distribute the load among these two. Got it? So what happens, instead of one container you have two containers, and the load is distributed. That means, suppose if you have 10 users requesting, 5 users will be reaching out container A of Gravitas, and 5 other people are reaching out container B of Gravitas, right? And that is a concept of load balancing and horizontal scaling. Horizontal scaling is nothing but adding new container, and load balancing is distributing the traffic among these containers. And what is service topology? Service topology is basically sending the details whatever he requested from the correct site. For example, so if a guy is requesting for Gravitas, he needs to get Gravitas page, and if a guy is requesting this thing, VIT homepage, he needs to get VIT homepage, right? And that is about service topology. It routes the whatever traffic. When you request the backend to go for that particular website, okay, you need to go to that website only. You're not supposed to, suppose for example, if you want to go to Rivera website, and if you reach to Gravitas website, that is not good, right? That is exactly about service topology. Okay, what are its features? I mean the other features. And so suppose if you have some static files or files you want to serve from the this thing cluster, Kubernetes cluster, okay, and so you can use storage archivization, which enables you to connect your network file system storage or Google Cloud storage to it, and you can serve all your static files or images or videos, whatever you want to share. Okay, and secret and configuration management are just for hidden files and hidden parameters. It's for hidden files or hidden parameters, so to serve them you use this. And automated rollouts and rollbacks, so whenever you make a mistake in the build file, okay, if build file gets failed, okay, it will roll back to the previous working version. That is the advantage of automated rollouts and rollbacks. And IPv4 and IPv6 support, and there's nothing much to explain in that. Okay, and self-healing is basically whenever the container gets crashed because of some reason, okay, and it automatically restarts or creates a new container. And it's declarative is basically you make a file of configuration file of all whatever services you want to do on whatever, how much load you want to handle, all the things, and it will automatically get deployed. I mean, it will automatically create resources based on whatever you mentioned in that particular configuration file. And over here, I guess he asked about nodes and cluster is basically the whole Kubernetes cluster. Okay, inside that you have nodes, okay, and nodes is basically virtual machines which will be powering the whole cluster. Okay, and then afterwards, all your code will be, all your code is turned into a Docker image, and Docker image will be deployed inside a Docker container. In one of these nodes, it automatically starts a container in one of these nodes based on the load and based on configuration whatever you have given. I hope I solved your doubt, and I hope I solved others' doubt of not understanding Kubernetes. Vidhi, can you explain how to create a VPC using deployment? You please post this in Telegram group, because we are not supposed to do a code along on a YouTube live according to Google terms and conditions. So I'm not supposed to do that over here. Mhm. Thanks a lot for attending the session, and hope you liked it. And if you have any other doubts, you can contact me on these particular social media handles. Thanks a lot.